This is a typical example of a small extended aeration plant where our product was introduced to reduce the ambient H2S levels. And without our product, the ambient levels around the plant were in the range of 25 ppm. And there were a significant number of neighborhood complaints. When our product was being introduced in the equalization tank, we saw a significant reduction of airborne H2S. And when we stopped using the product, the levels crept back to the pre-treatment condition. So we have a demonstrated, measurable, dramatic impact on the reduction of odor as our product is introduced into the front end of wastewater treatment plants. Similarly, we've done tests where we've looked at primary sludges that have not gone through anaerobic digestion. We've introduced the SR2 product into that primary sludge at about 50 milligrams per liter, and the primary sludge concentration is in the order of 2 to 3%. We see a 50% reduction in primary sludge odors as compared to control and other chemical products. When we've done the same test with thickened waste-activated sludge, we see at a dosage rate of 50 milligrams per liter, an odor reduction of 70% of H2S as compared to the control. And again, this thickened sludge has a concentration of 2 to 3%. When we go to blended sludge, a combination of primary and secondary, at dosage rates of 50 milligrams per liter, we see an 82% reduction in hydrogen sulfide generation rates. And these are closed container testing. We analyze the headspace of the closed container after 2 days of allowing the sludge to ferment on its own. So it's a fairly stringent test. We see immediate odor reductions within 1 to 2 hours after our product is being added to the sludge. So either we see an immediate effect and a long-term effect as sludge is being processed. This is a aerated lagoon example where the dissolved oxygen increased by 200% after our product was introduced to this aerated lagoon. So we raised the DO levels from around 1 to 2 ppm, and the lagoon system started to operate at a much higher efficiency, and there were no odors being generated from the facility at all. This is an activated sludge plant that treating about 3 million gallons per day, and we measured the energy consumption per 1,000 kilograms of BOD reduced or fed into the plant per day. So we measured horsepower demand to treat a standardized and normalized BOD load. The data is scattered, but when you normalize the calculations, we saw a 23% reduction in energy consumption with our product use. And we compared similar times of the year from one season to the next, so that there was no influence of temperature on the test results. This is a 6 million gallon per day plant in North Carolina, and we looked at the biomass yield, that is the kilograms of dry solids produced per kilogram of BOD and TSS loaded to the plant. Again, it's a normalized calculation, and after 3 months we saw a 33% reduction in the biomass yield at this facility. So that was a significant reduction in biosolids and resulted in significant cost reductions for the facility. This is a facultative lagoon that was faced with dredging the lagoon to remove biosolids every 3 to 5 years, and we saw that we started to accelerate the digestion of the existing sludge bed in the lagoon, and we at the same time reduced odors from the normal operation of the facility as well. So there was a cost benefit in digesting the sludge within the lagoon itself rather than dredging the lagoon, and we saw a significant odor reduction so that the neighborhoods surrounding the plant were no longer complaining about the operation of the lagoon facility. This is an RBC plant. Again, we saw a performance improvement. We saw nutrient removal in terms of ammonia increased from 0 to 65%. TSS removal increased dramatically. We eliminated the pin flock in the RBC effluent. The film on the discs improved dramatically. The fog slime that was evident on the disc disappeared, so we had a healthy porous biomass, and at the same time we eliminated odors being generated by the facility. In terms of performance, I go back to the 6 million gallon per day plant. We saw 15–20% reduction in TSS and BOD coming out of the plant, but the dramatic results were in the reduction of ammonia. Before the plant, effluent was nitrification was not occurring, and with our product we saw 70 to 80% reduction in ammonia levels. We also saw some reduction in total P as the phosphorus settled out in the clarifiers, and as a result of the better performance on taking out suspended solids.